This is question number 1 in the non-calculator. Part A, we have 5 1/6, take away 2 1/4. So we're subtracting two mixed numbers. When we're adding or subtracting mixed numbers, we can simply add or subtract the whole number parts first. Subtraction can sometimes be a little bit tricky. This, however, doesn't work for times and dividing, so bear that in mind. So, first of all, our 5 1/6 take away 2 will leave us with 3 1/6. That just leaves the quarter to subtract. So the 1/6 take away a quarter part. We can't do that until the denominators are the same. And the best way to do that is make both denominators 12. So we can achieve that by multiplying the first one by 2, which means we need to multiply the numerator by 2, and multiplying the second one by 3, again multiplying the numerator by the same amount. So that then gives us 3 2/12, take away 3/12. Now, when I mentioned earlier on that sometimes subtraction can be a little bit tricky, this is exactly the sort of situation that I meant. 2/12 is not big enough to subtract 3/12. We can get round this by using one of our whole numbers in here where we have the number 3 and give it to the 2/12 part, which will then turn 2/12 into a top heavy fraction, which will then be able to subtract the 3/12 part. So what does that give us? Well, that leaves us with two whole numbers. Giving the whole number to the 2/12 makes that 14/12, our top heavy fraction. Take away 3/12. So now we have 2 14/12, take away 3/12, which leaves us with 2 11/12. That's our final answer and the end of the question. Question 1b in the non-calculator paper. We have 3 1/2 multiplied by 2 2/3, so multiplication of two mixed numbers. The best way to do that is to change the mixed numbers into top heavy fractions. So we have 3 1/2 first of all. So to change it to a top heavy fraction, we take the 3 and we multiply it by the denominator 2. 3 times 2 is 6. Then add the 1 on, which gives us 7, which gives us our new numerator. The denominator stays the same, 2. And then we multiply, and 2 2/3, the same thing again. We take the 2, the whole number, multiply it by this denominator. 2 3s are 6. Add the 2 on the top. That gives us 8 as our new numerator. Once again, the denominator stays the same. So the process for multiplying fractions after this point is fairly easy. We just do top times top, 7 times 8, which is 56. And then bottom times bottom, 2 times 3 is 6. We now have a top heavy fraction, which can simplify. 6 goes into 56 9 times. 6 9s are 54, which leaves us with a remainder of 2, which goes on the top, and a denominator 6 on the bottom. So we have a mixed number, 9 2/6. The fraction part does simplify. So 9 2/6 becomes 9 1/3. Now this is our final answer, but there was an alternative step available at the point where we found our two top heavy fractions. So we'll go back to that point just now. That's this point here. If we remember that any numerator can cancel with any denominator when we are multiplying fractions, then what we should see here is that 8 and 2 will simplify. So 2 goes into both of those, 2 goes into 2 once, and 2 goes into 8 4 times. If we check the other two, 7 and 3, we can see that no simplification is possible there. In another question where the numbers were much higher or bigger at this stage, then that would make the next part of the question much easier to attempt. It's not so obvious the benefits in this question because our numbers are relatively low. but nevertheless it's worth bearing in mind for another question. So same as before, we do top times top, 7 times 4, which is 28, and then bottom times bottom, which is now 1 times 3, which is 3. So once again, we have a top-heavy fraction, which can be changed to a mixed number. 28 divided by 3, well, that goes 9 times. 3 nines are 27, leaving a remainder of 1, which goes on the numerator. And the denominator stays the same, it stays as 3. So we end up with the same answer as expected, with no simplification on the final line necessary. This is question number 2 in the non-calculator. Part A, expand and collect the like terms from our double brackets. So we want to multiply everything from bracket 1 by everything from bracket 2. So we'll do that one thing at a time. So we'll take the first thing from the first bracket, which is x, multiply it by the second bracket, which is x plus 3. Then take the second thing from the first bracket, negative 1, and multiply it by the second bracket, x plus 3. That then gives us x times x, which is x squared, plus x times 3, which is 3x. Then we have negative 1 times x, which is negative x, and then negative 1 times 3, which is negative 3. So now, next step is to simplify what we have left by looking for like terms. So we have positive 3x and negative x in the middle. The other terms are individual terms with no like terms. So we have our x squared. Positive 3x take away x is positive 2x, and then our negative 3 on at the end. It's fully simplified now, so that's our final answer. Question 2, part B. Again, we are to expand and collect the like terms. The second bracket this time contains 3 terms. It's the same process. We want to multiply everything from bracket 1 by everything in bracket 2. So we take that one at a time. So the first thing is our x from the first bracket. We multiply that by the second bracket, x squared plus 4x plus 7. Then we take the second thing from the first bracket, negative 2, and multiply it by the second bracket, x squared plus 4x plus 7. So x times x squared gives us x cubed. Then we have x times 4x, which is 4x squared. Then x times 7, which is 7x. Moving on to the second bracket, negative 2 times x squared is negative 2x squared. Then negative 2 times 4x is negative 8x. And then negative 2 times 7 is negative 14. So once again, we are looking to simplify by collecting the like terms. So we have positive 4x squared, and then later on we have negative 2x squared. And we also have positive 7x, and then later on we have negative 8x. All the other terms are individual terms. So on the next line, we start with our x cubed. Moving on to the squared terms, we have 4x squared take away 2x squared, which is positive 2x squared. Then we have our positive 7x take away 8x, which leaves us with negative x. And then we have our individual negative 14 term at the end. There are no more like terms, so it's fully simplified, which means we have our final answer. This is question number 3 in the non-calculator section. The value of a kettle falls by 40% and it is now worth £18. What was the value before the fall in value? This is another example of reversing the percentage change. Our original value of the kettle before the fall in value would have been represented by 100%, and that's the value that we are trying to find. It has fallen by 40%, which means its value is now represented by 60%. So 60% represents the current value, which is £18. We need to find a way of getting back to the original percentage value, 100%. So we need to find an in-between percentage to help us get there. That percentage is going to be 20%. We've chosen this one because we can easily divide 60% to get 20%, and then we can easily multiply 20% to get back to 100%. So that involves dividing 60 by 3, which means we divide the other side by 3 also. So £18 divided by 3 is £6. What we want to do next is multiply our 20% by 5 to get back to 100%, which means we'll do the same on the other side as well, multiplying by 5. 5 times 6 is 30, which gives us our original value, 100%, and that's £30, our final answer. Question number 4 in the non-calculator, we're asked to solve an equation. Part A, we have 5x plus 1 equals 46. So what we're going to do is we're going to collect the letter terms on the left-hand side of the equal sign and all the numbered terms on the right-hand side. So that means immediately our plus 1 will need to move across the equal sign. So the things that aren't moving, 5x will remain on the left-hand side and 46 is already on the right-hand side. Our plus 1, when it jumps across the equal sign, will change to minus 1. So that then gives us 5x equals 45. The next thing that has to move across the equal sign is our remaining number. So that number is 5. Currently it is multiplying the x, which means when we take it to the other side, it will divide the 45. So we get x equals 45 divided by 5. 45 divided by 5 is exactly 9, so x equals 9 is our final answer. Question 4b, we have another equation to solve. So we're going to use the same technique as before. We're going to gather all the letters to the left-hand side and all the numbers to the right-hand side. As you can see, when we look at this one to begin with, it looks a little back to front. And the simplest way to deal with that straight away is just by flipping the equation round. So instead of 7 equals 2g plus 9, we will write 2g plus 9 equals 7, which is obviously the same. Now we are going to start to move things around individually. So the first thing we're going to move is our positive 9. Taking that across the equal sign will make it negative 9. So we're left with 2g on the left hand side. We already have 7 over here. The positive 9 comes over and becomes negative 9. So that gives us 2g equals 7 take away 9, which is negative 2. So we have one more number to move across, this 2, which is multiplying the g. So when we take it to the other side, it will divide. So we get g equals negative 2, and then we're dividing by 2. So we know that the answer is going to be negative because we have a negative divided by a positive number here. So g is going to be negative, and then it's just simply 2 divided by 2, which is 1. So g equals negative 1 is the final answer. Question number 5 in the non-calculator paper. We're asked to write each of the following in scientific notation. So part A, we're starting off with this big number, which is actually 4,800,000,000. So what we're going to do first is to find out where the decimal point is. So if the decimal point is not shown, then that means that the decimal point is on the end. Okay, that's because we have a whole number. Now we want to move the decimal point into a position so that the number to the left of the decimal point is a single digit whole number. So to make that easier to see where the jumps are, we'll make this a bit bigger. So our decimal point starts here. We're going to move it once, twice, 3, 4, 5, 6, 7, 8, 9 times so that the decimal point ends up in here. So what that then gives us, that gives us 4.8 times 10 to the power of 9 because we had 9 jumps. That's our number written in scientific notation or standard form, and that's our answer for part A. Part B, we have another number to convert to scientific notation. This time it's 302,000, another whole number. The decimal point is what we need to locate first, And once again, because it's a whole number, it means it's on here at the end. So once again, we'll make it a little bit bigger to see what's going on. We need to move the decimal point into a position such that the number to the left of the decimal point is a single digit whole number. So that involves moving it once, twice, 3, 4, 5 times so that we get it in here. So this time our answer is 3.02 times 10 to the power of, and we had 1, 2, 3, 4, 5 jumps, which gives us our power of 5. That's our answer in scientific notation, so that's the end of the question. This is question number 6, and the first one in the non-calculator section. A yacht is valued at £140,000. The value of the yacht is expected to fall at a rate of 8.8% per annum for the next 4 years. Find the value of the yacht in 4 years' time. So this is an example of a depreciation question. We take our initial value, which is 140,000, and we multiply by 100%, take away 8.8%. So 100 take away 8 is 92, take away the other 0.8, and that's 91.2. Writing that as a decimal is 0.912. It's over a period of 4 years, so that means our power on here is a 4. It's now just a case of working this out on our calculator. So doing that gives us an answer of £96,851.73. Now, predicting the value of a yacht in 4 years' time to the nearest penny doesn't seem a sensible thing to do. So it doesn't ask us to do this, but a more sensible answer might be to give the answer correct to the nearest £1,000. So we'll do that. That then gives us a value of £97,000. That seems a bit more sensible, and that's our final answer. This is question number 7 in the calculator paper. We're asked to calculate the length of side X, which is this one here. It's a right angled triangle. We know the length of the long side is 12 centimetres, and we know that the angle in here is 40 degrees. It should be obvious at this point that what we're dealing with here is a trigonometry question, so katoa. So the first thing that we're going to do is we're going to label the sides on our triangle. So given that we have the angle 40 degrees, this one opposite is known as the opposite side. The long side is known as the hypotenuse, and the side that we're trying to find here is the adjacent. The next thing to do is write down SOHCAHTOA, so that's what we'll do here. SOH, CAH, and TOA. So what we're trying to find is the length of the adjacent side. That's our question, so that means we're going to question mark the letter A's. What we do now is we can see that the hypotenuse is one of the sides that we're given, so we can tick off the H's. And since we know the angle is 40 degrees, then that means using our scientific calculator we can work out sine 40, cos 40, or tan 40. Now, what should happen once we have done that is that one of SOHCAHTOA should have all 3 bits marked. We can see that in this case that's true for Ka, so that's the one that we're going to use. The next thing we do is write down the thing that we have marked with the question mark, which is the letter A, the adjacent side, the one that we are trying to figure out. As we can see, the other 2 letters C and H are sitting alongside each other, which means we're dealing here with a multiplication. C stands for cos, so sine, cos or tan always goes with the angles, that's 40 degrees. As we said, it's a multiplication, and we're going to multiply by the hypotenuse. So the next line, A the adjacent, well, we know that as x, so we'll call it x. So that's cos 40 degrees multiplied by the hypotenuse. And the hypotenuse we know is 12 centimetres. So that's times 12. So to get our answer, the next thing we do is use our calculator. Cos 40 times 12, which gives us our answer for the length of x. So we'll correct that to 1 decimal place, which makes our answer 9.2 centimetres. That's the end of the question. This is question number 8 in our calculator paper. We're asked to calculate the length of x. X is the longest side here in our right angle triangle. We're given the two short sides. These are 15 centimetres and 20 centimetres. So with this information, we should realise that this is in fact a Pythagoras question. Since we are looking to find the length of the long side, it's going to be an addition Pythagoras. So the long side squared will be equal to the two short sides squared and added. So that's x squared equals 15 squared plus 20 squared. So x squared equals 15 squared, which is 225, plus 420 squared, which is 400. So that then gives us x squared equals 625. X will therefore be the square root of 625, which means x is in fact 25 centimetres exactly. That's the length of side x, so that's the answer.